Okay, so now we're going to talk about polar equations and how they're graphed. Now what happens is we're plotting points with a static, a singular r and a singular theta. Sometimes r is defined as a function itself, and what it does is creates really cool looking graphs. Sometimes they're circles and circles, as we mentioned, and some are more dynamic than that. Like this one here is going to be called a limison, and it's some kind of loop-de-loop graph with a little circle in the middle here. They're just really cool, and you can come up with, if you've ever played with a spirograph before, the toy that makes all kinds of loopy types of curves, this is actually, polar graphing is actually where that's generated from if you want to get an equation to model those. So here's what you do. You take the thetas in a table form, because theta is the input, so you put in a respective theta and an r as an output is generated, and so you face that angle. For instance, if I put in 0, you're facing directly to the right, and if you put a theta of 0 into this equation, you get 1 plus 3 sine of 0. The sine of 0 is 0, so you're going to want to have your unit circle handy. That's where these are going to come from, especially the ones that you're going to do. And that means we're going to do 1 plus 0, or a radius of 1. While facing 0, we're going to walk a radius of 1 and plot a point, and so I've got that there. Then we're going to put in 30 degrees into that r equation, and the sine of 30 is a half, so 1 plus 3 times a half is 1 plus 1.5, or 2.5. So while facing 30 degrees, we will plot a point at 2.5 rings out from there. And we just keep on going. So sine of 90 is 1, so 1 plus 3 times 1 is 3, radius of 4, 150 goes in, sine of 150 is a half, 1 plus 1.5 is 2.5 again. So when I plot those points, those are my first 4 points. They went in a kind of looping order. So notice they went in a spiraling order. And as I go along plotting more points in here, you're going to see that play out. You're going to see 1 plus 3 sine 180 while you're facing to the left, and so on as you plot those points with a respective radius. Face it and walk that radius. At 210, if you go, I marked 210 in there, that's the first time we had a negative radius of a half. So when you're facing 210, you're going to go backward from that negative half units. I'm about to plot that point right there. And so we've done a loop, and there's an order to how these have kind of plotted out. So later on I'll graph them all and give you a chance. There's face 270, walk backward 2 units, plotted that. And then facing 330, we're going to go back a half a unit. And facing 360, we're at a radius of 1. We've gotten back to where we started. We started and finished at the same point that I pointed to right there. So there's kind of you went a full circle, although it's not a circle. It makes this neat little loop. Now watch, that's the order. If I went through it, it went as a big swooping loop with a loop in the middle. So a little loop-to-loop. And so that's one of our limison types of graphs, and it has an inner loop. So face the radius, or I'm sorry, face the angle and walk the radius. And because our radius is defined as a function, you get this dynamic change in the radius, and it makes these cool little graphs. As you change your theta, the radius is changing as well, and it makes for really neat dynamic graphs. So next one, if you do cosine of 2 theta, the difficulty with this one is you have to remember you're doubling the angle you're putting in. So the 2 is multiplied by the angle theta, nothing else. And then you take the cosine of it. So the order of operations is first you double the angle when you plug it in, and then take the cosine of it using the unit circle values that you know and love. So putting in 0 and doubling it's still 0. Cosine of 0 is 1, and then 3 times 1 is 3. So when facing 0 degrees, we walk out 3 units and plot a point. That's our first point. Next point, same thing. You're doubling the 30-degree angle, which is a 60-degree angle, and the cosine of 60 is a half, and 3 times a half. So there's this order of operations from inside out. Double the angle, cosine times 3. Then you write your r, face the angle of 30, walk out 1.5 units, and plot your point. Okay, so that's some good stuff there's a lot to, I'm going to do a couple at a time here. Just what you can do is actually fill in the table if you like. That's what I do sometimes. I go through and just get all the values first. And then once I get a couple of points all lined up in that table, then you can see you're plotting all these points in a sequence. As your kind of angle opens up from 0 all the way around, you're getting a series of points, and I've got my table all filled in, so it's just a different way to do it. And then I can go in and just start plotting them bit by bit, like the first 3, boom, boom, boom. Went from far right at a radius of 3 all the way back to the origin. Then I can plot the next 3, and those loop back around underneath, and then I can keep going. So I kind of plotted them in order. Yeah, 1, 2, 3, 4, 5, 6, 7, and then they keep going, and they actually loop around on the other side. So then there's the 8th point there, and then the 9th point. And this is actually only halfway there. We're not quite done. So this is just the first half of it. Now I'll complete it. If I made a bigger table, you could keep plotting in. This one doesn't stop at 180 degrees. The graph actually won't complete until you keep going to 360 degrees. So right now we only have half of the graph, but if I did the rest of it, it would finish off and make this what we call a rose curve. And the bottom half is a mirror image of that top half. A lot of symmetry going on in these rose curves. So that's kind of your basic introduction to that whole process of graphing. And next we're going to talk about converting the functions.